Welcome back, Night Owls. This is Dr. Nighttime, and tonight we're solving a geometry problem. Find the distance from a vertex of a tetrahedron to its center. We're assuming a perfectly regular tetrahedron, right? Suppose that all of the edges have length L. And we want to know the distance from any of these corners to this red dot right in the middle. Assume that it's hard to show it in 3 dimensions, but assume that red dot is right in the center of this tetrahedron. So, before we start calculating exactly what it is, we know that the distance has to be less than L, right? Because you're looking for the distance between the vertex and its closest point, and you know that to go from corner to corner, if the edge length is L, well, that's longer than distance to the center. And the distance also has to be more than half of L. Just because if you were to think about it, if I'm going halfway across in one direction, well, now I have to swing out at an angle. And we also know that the distance has to scale linearly with L, right? If I double the edge length, then my distance in any linear dimension should also double. So we're looking for something of the form some constant times L. That constant has to be between 1/2 and 1. But now how do we calculate the exact constant? And the trick here, I didn't come up with this myself. It was one of my friends in undergrad who showed me this. Consider a cube of edge length E. You'll notice that the non-adjacent corners, these 4 dots that I have on the cube, 4 red dots, they're going to form a regular tetrahedron of edge length square root 2 times E. Okay? So we'll have L equals root 2 times E. Now we've changed it from saying we need to find the distance from the corner of a tetrahedron to center of a tetrahedron to we need to find the distance from a corner of a cube to center of a cube. And cubes are a little easier to work with because with everything at 90-degree angles to everything else, we can start using Pythagorean theorem. And if you're familiar with 3-dimensional version of Pythagorean theorem, you probably have a sense of where this is going. If not, I'm going to explain where the 3-dimensional version of Pythagorean theorem comes from. And then you'll see where it's going. So we want to find the distance from this red corner to this green center. To do that, first we want the length of this diagonal A. That diagonal A forms the hypotenuse of a right triangle with legs, length E over 2 and E over 2. So we get A equals square root E over 2 squared plus E over 2 squared. Then this diagonal B is the hypotenuse of a triangle with a vertical leg E over 2 and a horizontal, kind of that diagonal horizontal along the base, A. So B equals square root A squared plus E over 2 squared. Well, if A is square root of this stuff, A squared, you just get rid of the square root. So we get B equals square root of E over 2 squared plus E over 2 squared plus E over 2 squared. First 2 coming from squaring A, and then the third one from this vertical length. That gets us square root 3E over 2. And the 3-dimensional Pythagorean theorem always works this way. It's that if I have this diagonal D, it's first coordinate squared plus second coordinate squared plus third coordinate squared all under square root. Alright. Previously I said that L was root 2 times E, so doing substitution I get B equals root 3 over 2 root 2 L, or 0.612 L. I hope you found this useful. And if you liked what you saw and want to arrange private lessons, click the link in the description below. And until next time, this is Dr. Nighttime wishing you a good night.